everyone, it's Alyssa and welcome to You Can Learn Math.
Today we're talking about solving factoring by grouping. Factoring by grouping. This is most commonly seen with cubes. We're talking like x cubed is involved. You'll sometimes see it with x squareds. That's a little less common. You're usually introduced to this with cubes. So that's what we're going to be focused on today, is using it for solving polynomials that have cubes in them. Now there's a lot of variations on this, frankly. So we're going to go through them, and there's going to be 4 different examples. Yes, you're getting 4 whole examples. Aren't you just thrilled? Yeah, I know. I can feel your excitement through the screen. I'm a weirdo. I like factoring. Yeah, that makes me weird. I get it. I know. So we're going to start out with an introduction, explanation, and a sort of introductory problem. Then the next one is going to be when there doesn't appear to be a factor in one of the groups. The third one is going to be when there's opposite signs involved. And the last one is going to be when you have to do a second step of factoring after you think you're done. I'm going to put links down below so you can jump forward if one of those sounds like the specific problem you're dealing with. So the first one we're dealing with is our introduction to the concept. And it's going to be 12p cubed minus 21p squared plus 28p minus 49. Now the first thing, when we have grouping, we want to make sure that the exponents here are in descending order, and they already are. Third to the power of 3, to the power of 2, to the power of 1, and nothing is there. That's what we want. In rare cases, they may put it out of order. Make sure it's in that proper order. Grouping, you start with just what it sounds like. You're going to put these into 2 groups. The first 2, the cube and the square, and the last 2, the one with the lone variable and the one with nothing. Now the goal for this is to pull a factor out of each group. It is likely going to be the greatest common factor. I say likely just because there's that 1% chance where it's not the greatest common factor. And I don't want to say absolutes. And then you go, but you said it would be. No, I know. Few things are absolute in life, and that's true in math as well. So most of the time, the vast majority of the time, you're looking for the greatest common factor. If you need a refresher on this, there's a video down below for greatest common factors. And the goal is going to be to pull out a factor that leaves identical binomials behind. And let me show you what I mean by that. I start over here on the left. I want to look for the greatest factor in the numbers and also the greatest factor in the variables. Let's start with the numbers first. I have 12 and 21. Think of 12 as 1 times 12, 2 times 6, 3 times 4. Do any of those numbers, 1, 12, 2, 6, 3, or 4, go into 21? And if so, which is the biggest? Well, 3. 21 is fewer factors. It's 1 times 21 and 3 times 7. So 3 is the biggest that goes into both of them. So that's my greatest common factor. I'm going to write down 3. Now, what's the biggest variable factor? Hint, it's always going to be the smaller of the 2. In this case, p squared is smaller than p cubed. It's going to be p squared. It's always the smaller one. It just is. So p squared comes out of both of those. If you take p squared out of p cubed, you're left with p, because p squared times p equals p cubed. If you need a refresher on exponents and why that works, again, link is down below for a video solely on that. So because I'm pulling out or dividing this by p squared, I'm left with p. All right, so inside the parentheses, what is left behind? 12p cubed divided by 3p squared. 12 divided by 3 is 4. P cubed divided by p squared is just p. Our second one, negative 21p squared. When I divide that by 3p squared, negative 21 divided by 3 is negative 7. And then p squared divided by p squared is 1. So there's nothing else for me to put. So I've pulled out 3p squared and I'm left with 4p minus 7. Now, when I go to the second half of this, the second group over here, I'm going to be looking for a factor that when I pull it out, and I have that little binomial left behind in the parentheses, it needs to match this. It needs to match 4p minus 7. And it should happen naturally when you pull out the greatest common factor. Sometimes that's not the case. It does happen where it's not the case, but the majority of the time, if you pull out the greatest common factor, you're going to be left with this same binomial, in this case, 4p minus 7. And it's a good sort of metric or a test to see if you've done it right, to make sure that binomial that's left behind matches. So what's the greatest common factor of 28p and negative 49? Well, I don't have to worry about the p's because there's no p here, so I'm not going to pull out a p. All I have to worry about is 28 and negative 49. Negative 49 is very limited in its factors, so I look at it first. It's 1 times 49 and 7 times 7. Does 49 go into 28? No. Does 7 go into 28? Yes. There's my factor. 7 goes into 28 4 times, and it goes into 49 7 times. Hey! So I'm going to pull out a 7 because that's the greatest common factor. And what's left behind? 28p divided by 7 is 4p. And negative 49 divided by 7 is negative 7. And voila, it has matched. Yay! The crowd goes wild. That's what we want. If it doesn't match, you can't go to this next step. It has to match. The next step is you are going to combine these two into a new little binomial in a parentheses. Okay? And you're also left with 4p minus 7. The reason this works, if you're wondering, what? Why are you doing that? If I change that 4p minus 7, and I said, I have 3p squared boxes of apples, and I added 7 boxes of apples, what would I have? I would have 3p squared plus 7 boxes of apples. I know I'm using words instead of math, using words instead of numbers there for the apples, but I think it kind of helps a little bit in this case to see the principle of what we're dealing with. I don't want to spend too much time on that because we have so many examples to get through, but that's our general idea. It's the same kind of thing as like saying 4x's plus 3x's equals 7x's. You're saying 4 plus 3 times those x's. It's the same principle at work, but for these problems, all you really need to know is, yes, you can do that. But that's a little extra. That helps you remember why you can do this. So our answer there is 3p squared plus 7 times 4p minus 7. Once you get to this point, always, 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 especially this one over here that's the squared, but check both of them. Look for any additional factors that you can take out, because if there is anything else that you can factor, you are not done. That means if there is something you can divide these two numbers by, if this can be factored like as a difference of squares, you have to do it. You have to take that extra step. Okay, so the next one on our agenda is when it doesn't look like anything can come out. 8r cubed minus 64r squared plus r minus 8. And we group the first two and we group the last two because, as we said, they're already in descending order. R cubed, r squared, r nothing. So we just don't have to reorder them. We just group them. Now my eye's drawn over here to the r minus 8. I'm like, there's nothing I can take out of there. There's no factor that goes into r and 8. What am I supposed to do with that? I have to pull a factor. What do I do? Well, you can pull a factor, and it's 1. Now it seems like a cheat, but for this, that's what it is. That's the solution here. So keep that in your mind. We'll get to that in a second. On the left side, 8r cubed minus 64r squared. What goes into both of those? Well, the biggest common factor that goes into 8 and negative 64 is 8. So I'm going to pull that out. And the biggest common factor that goes into r cubed and r squared, again, it's always the smaller of the two, is r squared. And I'm going to pull that out. And what's left behind? 8r cubed divided by 8r squared leaves me 1r. Negative 64r squared divided by 8r squared. Again, I'm dividing these numbers by the numbers, the variables by the variables. So I'm dividing negative 64 by 8, which gives me negative 8. R squared divided by r squared is just 1, so I don't have to write that. Let me slide this in a little bit. Give me some more room. Okay, so I have 8r squared times r minus 8. And look over here, I've already got my r minus 8. You're like, oh, it matches that. Yay! Yeah, do not fall into this trap. Oh, I've seen students do that. Like, oh, okay, so 8r squared times r minus 8 plus r minus 8. All right, so that's 8r squared times r minus 8. Yay! No, it is not. It is not, because you're like, oh, I've got my 8r squared, and there's nothing there. So I pull those together, it leaves me 8r squared. Think about this logically for a second. Could that be true? Because this is 8r squared times r minus 8 plus this additional amount. I've added an additional amount. So how could it be just 8r squared times r minus 8, which is the same thing? It can't be the same thing as that because we have an additional. Where did that go? It's vanished. Don't make that mistake. The trick to this one is that this r minus 8 is the same as 1 times r minus 8. I have one quantity of r minus 8. It's the same principle as if I said 8 x's plus x. There's no 1 there, but it is 1x. Here over here, there's no number visible out there, but it is 1 r minus 8. There is an r minus 8 there. We have to count it. There's one of it. So now that I've done that, I can put those together, and I get 8r squared plus 1 times r minus 8. Again, final check. Can either of these be factored? No. 8r squared plus 1. Anytime you have a squared plus and a single number, that can't be factored. Except for if the 8 and the 1 have a factor that can be pulled out. Same thing over here. You can't pull out any r's, but if there is a number that goes into both of those, in this case there isn't, you have to factor that out. All right, third example. This is when we're dealing with opposite signs, when the signs don't match. And here's what I mean by that. We have 12x cubed plus 2x squared minus 30x minus 5. And the signs I'm talking about, so when we group these things together, this minus 30x, I'm going to change this to plus a negative so I can group that very easily and make sure that negative is sticking with the 30x. Now, when I say opposite signs, I'm talking about the first term in each group. So here I have a positive 12x cubed, but a negative 30x. They are different signs. And then we check, and sure enough, the second term in each group are also opposite from each other. This is a positive 2x squared. That's a negative 5. When that happens, you are going to pull a negative factor out of the second group. That's how you're going to solve it. So let's go through that. First one, 12x cubed plus 2x squared. What is the greatest common factor in the numbers 12 and 2? That would be 2. I pull out a 2. What's the greatest common factor in the x's? X cubed and x squared. It's always the smaller one, x squared. When I pull that out, what is left? 12x cubed divided by 2x squared. 12 divided by 2 is 6. X cubed divided by x squared is x. Then 2x squared divided by 2x squared, that's just 1 because they're the same. On the other side, we are going to need to pull out a negative greatest common factor. Why? Because if I don't do that, these pairs are not going to match. So let me just show you that. Let's say I just pulled out a positive. In this case, I will look at 30 and 5 and say 5 is the greatest common factor. What happens if I pull out a positive 5? I am left with negative 6x minus 1. That does not match. They are not identical. They have to be identical. When you have these signs that are opposites, you have to pull out a negative greatest common factor to make them match. So negative 30 and negative 5, I'm going to pull out a negative 5 as my greatest common factor. Negative 30x divided by negative 5 gives me positive 6x, and negative 5 divided by negative 5 gives me positive 1. Now those binomials match. Zoom out a little bit here. So now that I've gotten there, I can put those two together, and I have an answer of 2x squared minus 5 times 6x plus 1. And can either of these be factored anymore? No. I am done. Now for our final example, this is going to be where they really start throwing bigger numbers at you and where you definitely have to make sure you've checked the final factoring to see if anything else can be factored. So this one is 96 n cubed minus 84. So we are looking 9, there we go. 84 n squared plus 112 n minus 98. All right, our exponents are already in descending order, so that's good. My signs match, so I don't have to worry about pulling out a negative. And so I'm just going to group them. I'm going to look for the greatest common factor here. Now, depending on how you look at this, you're going to come up with one of two different things. Either way you go, you're going to have to do some additional factoring at the end. Okay, so with these, honestly, there's no hard and fast rule, especially when you get these bigger numbers, whether you should start with the first or the back, the front binomial or the second binomial. It doesn't really matter. Just look for a greatest common factor, whichever one you think would be easier. Me, I look at 96 and 84 and I go, oh, those are both on my 12s timetables. 96 is 12 times 8, 84 is 12 times 7. So 12 is my greatest common factor there. Woohoo, all right. I'm proud of myself for remembering my times tables. So I'm going to pull out for the number, I'm going to pull out 12. That's the greatest common factor of 96 and negative 84 here. And of n cubed and n squared, what comes out? Again, it's always the smaller one, n squared. And what's left behind? 96 divided by 12 is 8. N cubed divided by n squared is just n. 84 divided by 12, or negative 84 here, divided by 12 is negative 7. N squared divided by n squared is just 1, so I don't have to include that. Now, once you have this, part of your work is done for you. Don't try to find a greatest common factor over here, because honestly, the bigger the numbers you're dealing with, the more likely it is that the greatest common factor is not going to give you matching pairs. This is experience talking. Trust me on this. What you're going to want to do when you get to these big numbers is use this. This is a gift, this 8n minus 7. You know you're trying to get it to match over here, 8n minus 7. Divide by hand or with a calculator and figure out what number do I need to pull out to get an 8 behind. So 112 divided by what equals 8? It's 14. So that tells me I need to pull out 14. And then I double check and I say, okay, is 98 divided by 14 7? It is. All right, so like, woohoo, okay, I'm done. I got this. I pulled out these big numbers. I'm so proud of myself. And now I have my answer, but do you? Spoiler alert, you don't. So I've pulled them together and I get 12n squared plus 14 times 8n minus 7. And do you see what I see there? Because I see a 12 and a 14. Those have a factor in common. It's 2. I can pull 2 out of there. And what happens when I do that? When I pull the 2 out, I'm left with 6n squared plus 7. And the 8n minus 7 stays the same. So that, my friends, is my final answer. 2 times 6n squared plus 7 times 8n minus 7. And if you had gone the route of starting with this one over here, and getting the greatest common factor for that, you're still going to get the same thing. It doesn't matter. You're still going to get the same answer. Something some people might ask is, well, what if I missed the greatest common factor? If I didn't see it? That is a self-correcting problem if you always check at this point and make sure that you don't have anything left to factor. For example, let's say if you had started with this, the 112n minus 98, and let's say you had pulled out 7 instead of 14. And you said, oh, 7, they're both divisible by 7. I'm so proud of myself. And so you said, okay, I'm going to pull 7 out of both of them. And I pull out 7, and I'm going to get 16n minus 14. And then you use this trick. You're like, okay, I'm going to make the other side match this. And you're going to use that 16 minus n minus 14 on the other side. This is going to be one of your factors, 16n minus 14. So when you get to the bottom, when you get to the last stage, and you're going to end up, after you pull out 16n minus 14 out of this one, what you're going to end up with is 6n squared plus 7 times 16n minus 14. And if at that point you do like I told you to, and always, always, always check your final one to make sure, you're going to notice up 16n minus 14, that has a factor. I need to pull out 2. What happens when you pull out a 2? Pull out 2 and you're left with 8n minus 7. Does that look familiar? Yes, it does. I'm going to move the 2 to the front because that's the order we put these things in. And I am left with 2 times 6n squared plus 7 times 8n minus 7. That's a really weird looking 7 there. So it's the same answer. So this is just showing you, even if you don't find the greatest common factor on your first try, this is not the end of the world. You don't need to go back and redo things. You really don't. Just keep moving forward and make sure at the very end to check and see if there are additional factors that need to be pulled out.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.